Hi, mathletes. We're going to continue talking about quadratic functions and tables of values. After this lesson, you will be able to find missing values within a table or extending a table in either direction by using your knowledge of rates of change for quadratic relationships. For each quadratic table below, find the pattern and then all the missing values in each table. So notice here, we know that these relationships are quadratic already. We don't have to find that out. We're still going to start with our change in x and change in y to look at our rate of change because that's going to help us predict the missing values. You're going to find the change in x and the change in y. Notice that we're only finding the values that we know. I'm going to find all the x values though because that's going to help me determine if I can keep going with the same pattern with these remaining y values. Please do that now. So you'll notice that my change in x hopefully is the same as yours and that it's going by 1, and that my change in y is changing. It is not the same. So we have different rates of change, 11 over 1, 9 over 1, 7 over 1, 5 over 1, 3 over 1. It is not constant. I have many changes. And just to look up here at the number line, if you're unsure, especially when you have negatives, whether it's increasing by 11 or decreasing by 11, think about like negative 17 would be just off of what's visible on this number line. Negative 28 would be way off the charts, and you would be going to the right for those values. That's why these are increasing. So whenever our change in y is not constant, we want to look at what the second difference would be. And it's really important that we mark our changes in a neat and organized way so we can see what we're talking about. So between 11 and 9, that is decreasing by 2. 11 minus 2 gives me 9. 9 minus 2 would give me 7. 7 minus 2 gives me 5. And 5 minus 2 gives me 3. This is constant. So we know our rate of change is not constant, but the rate of change is changing by a constant amount. So our rate of change is decreasing by 2. And so you want to write that down. That lets us know that this is quadratic. Of course, we already knew that it was quadratic. And what I like to do here, because I need to find these changes to be able to predict our pattern, because it's not going to be the same thing that we're adding here. Some of you might be able to see, okay, I'm decreasing by 2 each time, so this is going to be just 1. And then I got to decrease this by 2, which is negative 1. And you can follow that on your number line. So when we're over here at 3, and you needed to go down 2, you can just kind of keep moving your arrow going down 2, and it shows you what those values are going to be. And those values are our change in y. So I was just finding each of those marks on here when I was going by 2. You always know that that second difference is going to remain constant when you're talking about a quadratic. So sometimes it's easier to fill this in and use a box as a placeholder for these places, and then think of 3 minus 2 gives you 1, 1 minus 2 gives you negative 1, and work backwards in that way if you didn't see it right away here. Now we have to use this pattern to predict our y values. So 7 plus 1 gives me 8. 8 minus 1 gives me 7. 7 minus 3 gives me 4. And 4 minus 5 gives me negative 1. Let's take a look to make sure this makes sense with the values that we have. Where is our vertex? And do the numbers match up? And you can see here, I can see that my 7s match, my 4s match, my negative 1s match. That must mean that my vertex is right here. You can also see the difference between my positive changes. Right here, I'm increasing, and then I'm decreasing. And so if you point between that, that's going to go to that negative 1, 8 as our vertex. Let's take a look at number 2. Do your changes in x and changes in y. So you can see that our change in x is increasing 1 each time, and our change in y are increasing by different amounts, 6, 10, 14, 18. Of course, we know this is going to happen because this is a quadratic function. It is time to do your second differences. So please do that now, and you will be finding that of the things that you know. So 6 minus 4 gives me plus 4 gives me 10. 10 plus 4 gives me 14, and 14 plus 4 gives me 18. Let's use that information to work backwards to fill in our table. So we know that we need to find these missing change in y values, but we know that the change of the change, that our second difference is increasing by 4. So we know that something plus 4 gives me 6. You also know that 6 minus 4, when you go up the table, it's like you're subtracting, and you can find it that way. Looking up here at my number line, you can see that 6 is represented right here, and from 6 to 10 increasing by 4, from 10 to 14 increasing by 4, and from 4 to 18 would be also increasing by 4. That's off my number line, but I can work backwards and see that from 2 to 6, that would be right here, would be increasing by 4. So this is a positive 2, and then if I'm going to increase by 4 again, you're coming from negative 2. And then the last one is negative 6. So negative 6 plus 4 gives you negative 2. Negative 2 plus 4 gives you positive 2. Positive 2 plus 4 gives you 6. So this is in line with our pattern. And we have to work again backwards to get our y values. We've done these changes. And so what plus 2 gives you negative 5, or you can think of negative 5 minus 2 if you're going back up. And that's going to be negative 7. If we look on our number line, I wrote what we have here already up here. So from negative 7 to negative 5 is increasing by 2. That's shown right here. And then from negative 5 to 1 is increasing by 6. And from 1 to 11 is increasing by 10. You see that here. Now, when you're at negative 7 and you're working backwards, you're either going to add 2 if you're going back up, but if you're going from that previous value, you're going left 2 like we see here, and we see that that's going to be negative 5. And to subtract 6 from 1 is going to get that. So 1 minus 6, you see that that's going to give you to the negative 5, and then negative 5 minus 2 gives you negative 7. You can see on our table that this matches up. Our vertex, it's going to be between our changes in y that are decreasing and then increasing. You can also tell because you see the pattern here of negative 5 and negative 5 buddied up and 1 buddied up. And so between those partners is your negative 7. Let's write our rate of change. And remember, our rate of change is describing our rate of change. And in this case, it is increasing by 4. So these changes in y's are all increasing by 4. For question 3, like always, we're going to find our change in x and then our change in y. Again, for our change in x, you can see that these are all increasing by 1 as we go down here. You can also look at that on the number line. Those values are all going to the right by 1. My change in y's are differing again. This is not a surprise. We've already stated that these are quadratic functions, all 3 of them. And you can see right away where our vertex is. So I can see right here is between my increasing changes and my decreasing changes. And so this is going to be my vertex. You can tell that again because I am seeing my 16 and my 13 match up, and I can also see it right here because of the change in increasing and decreasing. Let's find our second differences. So we see we get a negative 2 here, that 3 to 1 is going down by 2, and then 1 to negative 1 is going down by 2, and negative 1 to negative 3 is going down by 2. And that means that our rate of change is decreasing by 2. Let's use this information to fill in the rest of our table. I generally think it's easier to work down our table because that's what we're most used to. And when we're at -3, which I have marked up here, I need to subtract 2. So I'm going to go to the left 2, and you can see that we're at -5. So that's this change right here. And then from -5, if I go further to the left 2, I'm at -7. And I can use that information. From 13, I need to subtract 5. So if I'm over here at 13 and I subtract 5, that's going to put me at 8. And if I'm at 8 and I need to subtract 7, that is going to put me all the way over here to 1, going to the left. Now I need to work up my table, but I can also use what I know about these patterns. So this should be 8 right here, and this should be 1 up here following our pattern. And we can see if that's the case. We can work backwards. So 3 something minus 2 gives me 3, and so that would be an increase of 5, and 8 plus 5 is 13. That matches up. And something minus 2 right here gives me 5. That's going to be 7, a positive 7, and then 1 plus 7 gives me 8. So this does match up. To quickly summarize what we've talked about in this lesson, work backwards to fill in the change in y and then the missing y values. Working backwards means we know the second difference is constant, and we can use that to predict our change in y's and then use that to predict our y values. I like to use a placeholder. Like I like to write a box in here to kind of hold the space for when I show that second difference. And on the practice problems, you may have tables that are linear, absolute value, or quadratic. Use what you know about the rates of change and the patterns in the rates of change to work backwards. So linear is constant. Absolute value is going to have 2 different constant opposite rates, and then absolute value with the second difference being constant.